Hi everyone. So today we are going to learn about additive property of Poisson distribution. Okay. So as I told you that for degree semester 2 first start students, additive property is very important. So one question they will ask definitely. Okay. So today we are going to learn about additive property of Poisson distribution. First we have to write what statement. Okay. సో మీ అందరికీ తెలుసు ఎడిటివ్ ప్రాపర్టీ అనేది ఏంటో అనేది. సో యూ ఆల్ నో దట్ వాట్ ఈజ్ ఎడిటివ్ ప్రాపర్టీ. సో ఇఫ్ యూ టేక్ సమ్ variables in Poisson distribution which belongs to Poisson distribution, if you add those variables, the result also should be belongs to Poisson distribution. That is called as what? Additive property. Okay na? Yeah, see here, the sum of independent Poisson variates is also a Poisson variate. Or else you can say if x1, x2 and so on xn are n independent Poisson variates with parameters what? Lambda 1, lambda 2 and so on lambda n. Okay, we all know that for Poisson distribution lambda is only the parameter. Okay, so now what we have to prove is the sum of independent Poisson variates is also a Poisson variate. We have to prove. That means what? Summation xi also Poisson variate. Okay, Poisson variate with parameter what? With parameter summation lambda I. Okay, so this one we have to prove. So for that what we have to write is, first what they have given we have to write. So as I told you that in my previous video, so every time if you are going to prove additive property, it based on what? Moment generating function. So now depending on the moment generating function only we are going to prove additive property. So for that we have to remember the moment generating function. Okay, so given that x1, x2 and so on xn are n independent Poisson variates. Okay, with parameters what? With parameters lambda 1, lambda 2 and so on lambda n. Okay, so now what we have to do is, we know that what we know? Moment generating function. We know that mgf of what? Mgf of Poisson distribution is what? Mx of t equals to e power lambda into e power t minus 1. This is the moment generating function of Poisson distribution. Okay, so first we have to take x1. So that mx1 of t equals to e to the power of lambda 1 into e power t minus 1. Similarly, mx2 of t equals to e power lambda 2 into e to the power of t minus 1 and so on. At last what we have to take? mxn of t equals to what? E to the power of lambda n into e to the power of t minus 1. Okay, so now what we have to consider is, now consider m x1 plus x2 plus and so on plus xn of t equals to, how we can write this one? mx1 of t into mx2 of t and so on mxn of t. So that equals to mx1 of t, in the sense what we can write, e to the power of lambda 1 into e to the power of t minus 1 we can write. Similarly, we can write these values also. So e to the power of lambda 1 into e power t minus 1, e to the power of lambda 2 into e to the power of t minus 1, and so on, e to the power of lambda n into e to the power of t minus 1. So as we know that here we can add powers. So that equals to e to the power of lambda 1 plus lambda 2 plus lambda 3 plus and so on plus lambda n of e power t minus 1. So here we can write, in place of this, what we can write, e to the power of summation I equals to 1 to n lambda I into e power t minus 1. Okay, similarly what we can write this side, m of summation I equals to 1 to n xi of t. So that means what? If we take here summation, here also we got summation. Okay, so ikkada manam summation తీసుకుంటే ఇక్కడ కూడా మనం summation రాయగలిగాము. So that shows that additive property is satisfied. Okay, so this is about Poisson distribution additive property. So don't forget, additive property is also called as reproductive property. Okay, hope you all understand. If you are watching for the first time, don't forget to subscribe my channel, share with your friends. Have a nice day. Bye. Take care.